The spiral of a football shows angular momentum, represented as L equals mvr as it spirals through the air. As it spins on its axis of symmetry from a perfect throw, it has its smallest radius, letting it fly faster and straighter as the momentum is centered with the spinning axis. The football, with a mass of 0.425 kilograms, spinning around its axis of 0.5334 meters, has a relative velocity of 4 meters per second. This makes the total momentum of the football 0.9067 kilograms times meters squared over seconds. The momentum is focused around the axis of symmetry and flies straighter and further. Now the football isn't properly thrown, so it is ducking. We can still use the same formula L equals mvr to find the angular momentum. With the football flying wildly, it still has a mass of 0.425 kilograms, but now the axis the ball rotates around is much larger, 0.7112 meters, 20 centimeters more than the other football. Although thrown with the same force, it now has a relative velocity of 3 meters per second. Surprisingly, it still has the same momentum as the other throw, 0.9067 kilograms times meters squared over seconds. This is because of conservation of momentum. The radius does not line up with the axis of symmetry, so the football ducks. Spinning in a chair is another example of angular momentum. As the weights are brought in, the equation L equals mvr changes. Before, when the weights were held out, her radius was large, and to conserve angular momentum, her velocity had to be small. As the weights were brought in, this was reversed. Her velocity was able to increase as her radius decreased, allowing her to spin faster. Wheels of different masses and the same speed will slow down at different rates. This tire took a minute to stop, while the scooter only takes seconds. The larger mass and radius of the tire gives it more momentum and allows it to stay spinning longer. The scooter's mass and radius, on the other hand, is much smaller, so with less momentum, it slows down much quicker. Angular momentum can also be shown through spinning objects. With a mass of 1.13 kilograms, a velocity of 3 meters per second, and a radius of 1.3 meters, this weight has a total momentum of 4.407 kilograms times meter squared over second. Comparatively, the smaller weight will have a smaller angular momentum than a larger one spun at the same speed. As with the other weight, this still has a velocity of 3 meters per second and a radius of 1.3 meters, but its mass is now 1.36 kilograms. This totals to 5.304 kilograms times meter squared over seconds. This means the weight, once spinning, will be harder to stop, as it will want to conserve the momentum built up.